let's establish a few more things about climate patterns and climate responses. And as I mentioned in the last podcast, attributing the cause of change is a critical aspect of arguing for anthropogenic impacts on Earth's climate, right? So first you have to detect the signal. You take all the data and you say there is a change, either in the global mean temperature or sea level or arrival of spring, changes in behavior of certain birds, or whatever it is. Okay, so the best signal to look for is, of course, the changes in temperature, for which we have reasonably good data, which can be robustly used to claim attribution. So attribution is where you can say with confidence, quantifiable confidence, that the change is because of certain cause. Like in this case, typically when we say attribution, it's a human cause. Okay, so for that you need either enough data to separate the human impacts from natural variability, or you end up relying on models which can reproduce the observed warming, and then you take out the forcing from these models. In the models you can move mountains, you can move continents, you can change solar forcing, you can change CO2 amounts, and so on and so forth, and that's what is done. So there is the observed warming, especially increasing since the 70s, and the human forcing to put into the models produces the observed warming fairly reasonably. Okay, why do we say that? Because some uncertainties remain in how the land use has changed over time, how much population has had an impact. Various human activities and human agencies are not fully represented, as we talked about in the first chapter, and there are model formulation problems as well, because we don't know exactly how clouds work and how precipitation actually is extracted out of the clouds and so on. Okay, nonetheless, you need to establish confidence that models can produce the observed warming quite well. And the year-to-year variability in the real world is not going to be captured by the models, because it's not like a weather prediction that you say this is the weather tomorrow, tell me what it will be tomorrow. This will be just like starting at the beginning of the Industrial Revolution with 280 ppm of CO2 and whatever methane, nitrous oxide, aerosols, which are high uncertainties. Remember the level of confidence we looked at in the radiative forcing? That's what creates these problems. So keeping all that in mind, you take out the forcing of the solar variability and volcanic forcing, CO2 and so on, and you can see that the model then will not get any warming at all. The variability is quite flat with natural variability and so on and so forth. So that tells us that basically human impact is very critical for capturing the observed warming. This is done now everywhere, so models using only natural forcing and models using both natural and anthropogenic forcing. Okay, so you can see that on all continents and all oceans, North Pacific, South Pacific, North America, South America, and so on, including the Arctic and the Antarctic and Southern Ocean, there is a clear indication that without including the anthropogenic forcing, you just don't get the warming. Okay, so this is the sea ice loss, for example. Okay, if you don't have the human forcing, the sea ice loss just wouldn't have occurred. So this gives us confidence that at the global average scale and at regional scales, human impact is quite obvious. Okay, so when we talk about anthropogenic impacts on observed variability, we have to go back to see when did we start impacting things. People like Bill Ruddiman, who is a paleoclimatologist, would argue that our impact started as soon as we started agriculture, because we started clearing forests, settling down and building structures and so on and so forth. And that becomes critical in understanding variabilities like these, where the Harappan period, the summer monsoon and the annual rainfall kind of almost disappeared at some point around 2000 to 4000 years ago. And there is some idea as to what would have forced these in terms of the changes in the thermohaline circulation and so on. And there are many theories arguing what would have caused it in terms of the shift in the ITCZ, etc. And this civilization basically went extinct. There is lots of archaeological and other evidences to show that they were thriving, they were building lots of places, they were rich in agriculture, trading, and suddenly, boom, they kind of disappeared over some time. So anthropogenic impacts have to be kept in that context. Now, IPCC's last report in 2014 compiled all the evidence there is for human impacts on physical systems like glaciers, snow, ice, rivers, and so on, coastal erosion and sea level effects, biological systems, terrestrial marine ecosystems, wildlife, marine ecosystems, as I said, human and managed systems like food production, livelihoods, health, and economics, and compiled the impacts with various confidence levels shown as bars here, very low to very high confidence. And the main point to note is that on all continents, including polar regions of Arctic, and Antarctic, and the ocean regions including small islands and so on, there is a clear indication of impacts attributable to climate change, which itself is attributable to human emissions, anthropogenic greenhouse gases. And that is the story where we stand now. There is really not much room left to argue that humans are not having an impact. Okay, human fingerprints are all over as well. Cooling of the upper atmosphere, as you trap more energy in the lower atmosphere. To first order, that reduces the amount of energy going out, so upper atmosphere gets cooled a little. Winters are warming faster than summer, which is what we expect in terms of circulation changes. Nights warming faster than day, again dynamically explained. More fossil fuel carbon in the trees and in the air. So it's not like CO2 is measured and we don't know where it came from. We can look at carbon isotopes, oxygen isotopes, and so on to say it is in fact coming from burning the hydrocarbon in the fossil fuels. This is a key evidence as well. Less oxygen in the air, less heat escaping to space, more heat returning to Earth, more fossil fuel carbon in the air as well as in trees, and patterns of ocean warming are explained, more fossil fuel carbon in the corals as well. Okay, so all in all, huge compilation of evidence for human impact, with the evidence that the emissions are actually coming from fossil fuel burning. Okay, so for this course we will keep visiting some of these issues again and again, but in this chapter we're establishing the basics of each section so that you are comfortable as we go forward. But as I said, in another course on Earth's climate, past, present, and future, I have many more details of each of these topics. And in the ocean atmosphere dynamics and in oceanography course, which are all on YouTube channel, have the details you can follow up on as podcasts. Okay,